1971. Find if path exists in graph. So we are going to find a path from source to destination. So if it is connected, so we're gonna return true. If there's no such path, we're gonna return false. So for example, this edge is like 0, 1, 2. So we're gonna check 0 to 2. It is connected, so we're gonna return true. So for this one, we're gonna check source 0 to 5. It is not connected, so we're gonna return false. So the value of n is 2 times 10 to the power of 5. So it means that there's a 10 to the power of 5 nodes. So we're gonna use BFS to solve the problem. I have solved the problem by unified before. If you can check my videos, that is unified. Basically, we just need to use the template, and it's basically a unified template. But for this problem, I prefer to solve it by DFS this time, because DFS is easier to write. Now let's just get started. So I'm gonna prepare a existence list. So it's gonna be a default dict. Inside it's gonna be list. So for UV in edges, I'm gonna prepare this existence list. So it is undirected graph. So gu.append v and gv.append u. So I connected all of them. Now I'm going to check if the source connected to the destination. So I'm gonna prepare a weighted set. So weighted would be set inside. I'm gonna have the source. Now I'm gonna I put the source inside the weighted. Now I just need to check the DFS. So for me, I'm gonna use the DFS just like a graph traversal. I'm gonna traverse all the nodes. If it is not possible, for example, for this node 0, I'm gonna traverse all the nodes like 0, 1, 0, 2, and similarly for this one 0, 1, and 1 to 2 until I checked all of the possible results. So I'm gonna set a self.result to false from the beginning, and then I'm gonna execute the DFS. It's gonna starting from the source. After executing, I'm gonna return this self.result. So if it is true, so it's gonna be true. Now I'm gonna write the DFS function. So inside it's gonna be the source. So if source, basically if there is a true, so I'm gonna set this result to true. I mean, from here you cannot return true immediately from here, because even if you return true, the DFS didn't execute it. So but what if you return a false here? So for each of the time it will return a false, but you cannot do it like this. So if you are using the DFS like the traversal one by one, so you have to set a result to true. If it is true, so the result would be true. If it is a false, it will not set to true, it will be the false. Now let me run it to check. As you can see, it works. Now let me submit it to check. As you can see, it works. Although it is not so fast, but basically the time complexity is just O(n). It is the number of vertices and edges, because the edges is also like 2 times 10 to the power of 5, and the vertices is also like that. So I'm gonna say the time complexity would be O(n). Actually, it is O(e) plus v. Thank you for watching. See you next time.